Today we're going to talk about hardware, in particular the computer system and those components that go into making up the computer system. A system, definition, a collection of subsystems that work together to make a whole, produce a product, perform some process. And if you think about it, virtually everything can be viewed in terms of being a system. A human body itself is made up of a skeletal system and a respiratory subsystem and a digestive subsystem and many more. A factory, let's say a toy factory, is made up of numerous subsystems. Accounting, manufacturing, marketing, all go into making that one system to manufacture toys. And a computer system is the same way. It is a system that's made up of many subcomponents. The difference is in what this particular system does compared to other systems. For example, this system purpose usually is to convert data, which is text and numbers and so on, that in itself does not really have much value because it's not in a form that can be used. And a computer converts that data into information, which is data that is processed in an organized and meaningful way. I often say a data is to information as hamburger meat is to a Big Mac. It makes it useful. And that's what a computer system does, usually. Now, all systems have basic functions that they perform. There is the input function. You have to get something into the system, whether it's raw materials to make that toy, or it's food for that human being to operate, or data for the computer to process. Then some process occurs, and then there is output. All systems have these things in common. Now, when we talk about computers, we often add this little category right here, storage. But if you really think about it, storage is just another form of output. And so we're going to discuss the computer system and its components in terms of these basic functions of input, process, and output. We'll begin with the keyboard. Obviously, the most common input device that most of us are aware of for a computer. This device that you're looking here on the screen was invented around 1910. It's called a QWERTY keyboard because of this series of keys right here along this row. And this is a piece of equipment that is over 100 years old that we are still using on state-of-the-art computer equipment. And if you look at one of these things, you'll soon find out that they're not built for human beings. If you were sitting at your desk and just raised your hands to your waist in a normal manner, what you would find is your hands come up at kind of an angle. The left hand comes up sort of like that. The right hand comes up sort of like that. And in order to use this computer, you have to twist them in order to manipulate those keys. And that twisting can be hazardous to your well-being. It creates a disease, perhaps you've heard of it. It's been known to do this, called carpal tunnel syndrome. Very common disease among people who work with machinery and work with their hands. Seamstresses and others that work on equipment like that, and people who work on a computer a lot during the day. So we have this device that's over 100 years old that we just haven't been able to get rid of. We continue to look for ways to try to get data into a computer better, voice recognition units so that we can speak to the computer. But we end up having to fix our voice recognized data with the keyboard usually because it's rarely, at least my experience has been, that it rarely picks it up exactly like I meant for it to. Another input device that we are very familiar with is the mouse that you see right here. You recall in an earlier lecture on the history of computers, I talked about a gentleman named Doug Engelbart. And Doug Engelbart is the man in the early 60s who was one that came up with this device, the mouse. And it more or less languished for 20 or 30 years until about 1980 when some of the computer companies began developing computers that you interfaced with via graphics rather than the keyboard and text. These were called Graphical User Interface, GUIs, and you're most familiar probably with the Macintosh, and of course Windows that you may be using right here to watch this are all graphical user interface type devices, and it's the mouse that's made that possible, and the mouse would be an input device. Here's another input device. Don't often think about it that way, but the fact is I'm using one right now to record this video. Now the one I have is a headset with a mic hanging off the end of it, but it's the same type of thing, and it is in fact putting data into the computer, making it an input device. Here's one that you may be very familiar with, the scanner. Imaging has become a major part of business today, getting data from paper to the systems. And this scanner right here, of course, looks like it's one of the more inexpensive ones out there, but you can use that to scan documents, graphics, images into your computer system. A very, very popular input device. Speaking of scanning, here's a good one. This is a barcode reader. It's a scanner. Those of us that were around in the 50s and 60s remember going to the grocery store and watching the lady at the cash register as she checked customers out. This lady was probably among the highest paid people within that organization because it took a lot of skill to do that. She had to sit there and take those boxes and cans out of the buggy and would be inputting the sale price or the price of it into the cash register in order to process the sale. And then along comes scanning and this little barcode right here. And now all of a sudden, the person that's actually scanning things into the computer may not have to be all that highly skilled and highly well trained. They just have to have the skill to point this thing at the barcode or drag the item across a stationary reader to input the data into the system. And more important than that, though, when that lady in those early days was inputting that data, the only thing that was being accomplished was that she was adding up the cost of your sale to get your money. Today, when that scan takes place, a whole lot of things happen. It's input into the computer system. The accounting system is updated to indicate to show the sale. Quite often, in some organizations, that sale automatically arrives at a vendor's system where they reorder the replacement for the item you just bought, and perhaps the truck is lining up at the door tonight to restock what you just purchased. This modern technology has made it possible to be very, very competitive and get a lot of work done with minimal amount of labor. The barcode reader. Speaking of barcode readers, this is one. This is a UPC code, Universal Product Code is what that means. And this is a QR code over here. This other one, that is a different type of code. QR stands for Quick Response. It was originally started in the automotive industry, but we're seeing these more and more often these days in magazines, newspapers, and books and other places like that, where you can point your smartphone at it with your camera or a scanner app in your phone, which, by the way, is another input device to a computer, and take a shot of that, and it might direct your smartphone to a website where you get to watch a video or see information that you might be able to use. Extremely powerful tools, these codes and these readers. A check. Why do we have a check in a discussion of computers? Because of these characters right here at the bottom of this screen. Those are not just printed on there in ink. Those are put on there with a special kind of magnetic ink. You look at those numbers and what you see are a routing number to the bank. Your account number would be right there. And if you look at the top of your check, you'll notice that that same number is the check number. And that allows banks to process thousands upon thousands of transactions very quickly because the data entry is limited to inputting the check amount at the time that they put it into their system. And quite frankly, today, much of that's automated. Perhaps you've been at a store where you've given them a check and they have stuck it in their scanner and then handed you your check back, because the input into the bank system took place right there at the point of sale because of the use of these magnetic characters. The device that prints this is called a magnetic ink inscriber, magnetic ink inscriber, and the part that reads it is called a magnetic ink reader. Magnetic ink reader. You can place the word ink in there for me. All right, so that is a very, very powerful input device, the magnetic ink inscriber or reader. Here you see a picture of the internal workings of a hard disk, a storage unit, and notice that both our input and our output words are highlighted. That's because this device is both an input device and an output device, in addition to the fact that it's a storage device. When you turn on your computer, data written on tracks, which are concentric rings on this disk, and this is a magnetic storage. Data is stored on here in a magnetic symbol, and that data is read into your computer system as the program. And then when you actually save the data, let's say you type in a letter in Word or Excel, that data is then written back, making it an output device, get written back to that disk. So that is another very powerful basic function product of a computer. What is this one? Well, it looks like the same kind of a thing almost, and it nearly is. This is a DVD or a CD, and but this is not magnetic. This device stores data by creating blemishes on the surface of this disk. It still has tracks, just like the other one did. The advantage to this one is that it is not affected by magnetic fields, and so that makes it very reliable. And it's also portable. That hard disk is not portable. The advantage of that hard disk is that it is extremely fast and has very, very large capacities that this one does not have. Oh, you know what this guy is right here. What is it, a flash drive? Is that what you refer to that? Some of you call it a jump drive. Some of you call it something else. But this is another form of electronic storage, and it is both input and output, and it is also storage. We are moving away, as we have talked about in some of our classes, from worrying about this kind of technology, because we are beginning to start to save our data in the cloud, meaning that no longer do we have to worry about what kind of drive we've got and what kind of capacity we've got. If we need more capacity, we just tell them to add some more to our account and we buy it. Over the years, I have gone from a 5 megabyte hard disk, thinking it was the greatest thing in the world, to a terabyte hard disk, which I have yet to be able to fill up. So maybe finally with the old magnetic technology, I've reached a point where I don't have to worry about upgrading all the time. But still, the cloud is a much more effective and useful way to store your data, because you have access to it from any machine, anywhere, as long as you have access to the internet. Something that you don't have with these others. Oh yes, you can carry a flash drive around with you, but if you're like a lot of us college professors, you find that the drive that you've got, the flash drive that you put the lecture on for today, is at home, and the one I've got here is dated and it's old. By using the cloud, that problem is resolved. What is this? A telephone. Yeah, that's correct. This, in fact, is a computer. It's just a small computer, very special purpose computer. It's called a smartphone, and it can be an input and an output device in the computer. You are updating data. You're using it to input into your bank account to check your transactions. You're reading data from your bank account, all that sort of thing. This is a very, very useful input and output device. Also a storage device. If any of you have iTunes, you got your tunes on there. In the interest of equal time, here is an Android phone. Same thing. Oh, we got to talk about BlackBerry. Wouldn't want to hurt their feelings. So we have got 3 different types of input devices, 3 different types of smartphones. The monitor. Now, why do you suppose we have input and output highlighted here? Because the one that you're looking at here on the screen apparently is using Windows 8, and Windows 8, like many of the tablets using that you buy today, will utilize a touch-sensitive screen. So as a result, this device, the CPU, the monitor. This is an LCD monitor. Can be both an input device and an output device. There's an old dinosaur. This monitor was referred to as a CRT, which stood for cathode ray tube. They weighed a ton, took up a lot of space, and we couldn't wait to get rid of them. The LCD is much easier to handle, deal with, and use. All right, printers. This printer here appears to be some form of a laser printer. And a laser printer is a wonderful printer to use because it gives you excellent quality and it also gives you great speed. Now, printers can possibly be input devices. It is possible to have one as one of these 3-way or 3-function devices that both scans, prints, and faxes. So it could be more than that. This one appears to be just a straight laser printer. Well, here's a picture of an old one. You may have one of these at home. This is an inkjet printer, and this is the most inexpensive, effective way that you can get color output at a reasonable price. The inkjet printer is very popular, very good. Oh, this is an old job right here. This is called a dot matrix printer. A dot matrix printer makes the characters by firing pins through a ribbon and hitting a piece of paper, and it makes the characters out of dots, thus the name dot matrix printer. Now, I happen to love dot matrix printers because A, they're practically indestructible. I swear I've had some that I could take and throw out a second-story window and they'd still be working when I picked them up off the ground. They're very inexpensive to operate. A ribbon for one of these things is not expensive, and it's just a good, reliable piece of equipment. You will still see them in use in some industrial areas and in some office areas when they're just needing inexpensive output. This is kind of a special purpose printer here. This is called a plotter. A plotter. It's not a printer really, it's a plotter. And this device might be used by anybody doing graphical applications such as architects or engineers, and they make some beautiful products, beautiful work. Think about, here's another example where the technology has just revolutionized an industry. Instead of having a fellow standing there at his graphic board, drawing with a pencil and a ruler and erasing, they input the data into a computer and spit it out on that printer. And if they want to make a change, they just go back to the original, make their minor change, and then reprint it. Very, very, and they're usually fairly expensive, but very nice output devices. Well, what am I looking at here? Is that an output device? Is that an input device? What kind of device is that? I would say it's probably all of the above. That is a point-of-sale system, and that screen that you're looking at right there is probably a touch-sensitive screen so that they can input the transaction. Right in here is some sort of a printer, and that could be dot matrix. It could be a different kind, one that uses special paper that's heat-sensitive paper. And obviously there's a drawer here, and in all probability they pressed a keyboard key to make that drawer open, making that an output device. So there is a very common, popular output device today. What are we looking at? Speakers? Absolutely. As a matter of fact, I'll be listening to this video very soon with the same headphones that I'm wearing with this mic on it. Speakers are an output device. Now we're going to move to another topic here. We're going to talk about processing for a little while. Now, processing. That is, you've taken the data in, and your computer is going to perform some magic with it, and something's going to happen. And what happens is there is a device inside the computer that performs a number of functions. And back in the old days, you would have found a big machine like the one you see right here that had a number of devices that all worked together to accomplish that task. One of these big machines might have held memory for storing programs. Another one of these big machines might have had an arithmetic logic unit in it for doing calculations and so forth. And then in 1971, Intel invented a device which actually combined a lot of the machines that you saw on that previous screen into one chip. In fact, there it is. I think that's it. 4004, I'm not real sure, but that was among the very first one they ever made. This one here is a fairly modern one, and this is called a what? A microprocessor. You recall in an earlier lecture we talked about Robert Noyce at Intel, and they invented this device about 1971, and it combined a number of the components that you saw on that previous screen into a single silicon chip. And this is the device that does the actual processing of the data. It works very closely with an area of memory called RAM, which stands for Random Access Memory. Here is an internal schematic of a microprocessor, and here are the various kinds of components. You see right here, it says instruction decoder. This is part of a series of circuitry referred to as the control unit. And the control unit is responsible for actually going to get instructions out of memory and decoding those instructions and then issuing some sort of order to happen next. Now, generally what happens is when the computer system goes to the memory to pull in an instruction, when that instruction comes in, it has the address of the next instruction that will be called. And that address is peeled off and forwarded into this area, very high-speed memory called a register. This one is an instruction register, which is a very, very special purpose register to hold those instructions. And then the control unit decodes the instruction that it got. And let's say, for example, the instruction says, save this data. Let's call the data a 4. Well, the control unit will then put the 4 in one of these registers, these general purpose registers. We'll put it right here. And it stores a 4 in that register. Well, that finishes that instruction. Then it goes back to the instruction register, gets that instruction out, that address out, goes back to RAM, finds that address, pulls in the instruction that happens to be right there, and let's say, and then in first step it does is pull the address of the next instruction out of it, put it down here in the instruction register again, and then let's say that one says, put this other 4 somewhere quick. So it stores another 4 in another one of these high-speed registers or storage places. These storage locations are actually within the microprocessor itself. Well, then it goes back and gets the address back out of the register down here, the instruction register, and goes out to memory and gets that to that address and pulls in the next instruction. And let's say it decodes that instruction after it's already taken off the address of the next one. It decodes that instruction and it says, add those two numbers together. Well, the control unit doesn't add. The control unit passes that off to this device right here. You see it says ALU. That stands for Arithmetic Logic Unit. Arithmetic Logic Unit. And that is the device that does those kind of calculations, makes logical decisions. Is this bigger than that? Is this true or is this false? The Arithmetic Logic Unit does that. But the point of all this is that all these different components at one time were all different machines connected to the computer system. But today, They're all built into that one little silicon chip that has the processing speed that is phenomenal, where many of these instructions can be interpreted and processed one right after the other. Here's a picture of a motherboard. It's called a system board, or you will hear it referred to as the motherboard, quite frankly. It's a very common term. And this is the platform on which all of these devices are stored, are mounted. For example, it looks like the CPU is somewhere right there. Maybe that's the CPU there. I'm not real sure. This looks like an older board. You see some slots right here. Those are for putting external cards into your computer. Things that give you other features that maybe did not come with the computer. Like a lot of people like to buy special purpose video cards for playing games and things like that. And this is where they would plug those into those. Those are called I/O ports, input-output slots. All right. What else do we see over here? Oh, right in this area, right here, there are some chips that are standing sideways, some circuit boards that are actually mounted in there sideways, and that is actually RAM. That is the memory that is utilized by the microprocessor. And it goes out and gets your access or your data, your word processor, and brings it in and starts processing those instructions. So all of this really is the platform upon which all of the devices are mounted and connected to the microprocessor so that it can do its job. Well, there you go. There's another view of RAM right there. This is one that's a close-up view of that same series of slots. And these little circuit boards, they're called single inline memory modules, SIM modules. This is where your memory for your computer is stored. It looks like this computer here has got an additional slot that they could increase their memory with this. And this works very closely with your computer. Now I'm looking at the back of a computer because it has something that we should discuss. It is where various ports are located. Now you know what a port is. That's where a ship comes in and docks. Well, these are various ports in which devices can be plugged in, and they're connected to, see this one right here? That is a video port. So if there were a video, this one apparently, the motherboard has the video card actually built into it because it has its own video port. This one right here, that's another form of a video port. Also, so this particular computer appears to be able to support 2 different monitors. This is a keyboard port that you see right here, and that one they're moving away from those pretty much, and everybody's going to another kind of a port. And there you see one right there, and you should be very familiar with this, USBs. This is most of the devices we use today will plug into one of these USBs, which stands for Universal Serial Board, and that's how you connect your mouse, your keyboard, various other devices to it. These colored spots over here, that's where you would plug your audio equipment into, your speakers into. Now what you're seeing with this one right here, this, and then also with this one over here, the video cards, are still something that you will find usually is a separate interface card that would be plugged into one of those input-output ports, slots on the motherboard. But some motherboards come with them built in, and if you're not really expecting some sort of extra special video or sound or anything like that, they work perfectly well for most of us. What is that one right there? Isn't that your HDMI port that you would plug to your TV or connect some sort of a device to like that? So these ports are on the back of your computer, and this is how you connect all of these input and output devices to the computer. Now the hard drive is probably, you're not seeing it on this, but it's mounted in a carriage on the inside on that motherboard, around that motherboard over there, and it's plugged directly into the motherboard. Motherboard is not a port for it, but that's generally how a computer would look. And so there is there's a basic description of the input, process, and output hardware that we will often find with computers. Now we're going to talk a little bit about some various classes of computers. For example, mainframes. Mainframes are large, high-performance, multi-user computer systems. Been around since the early days of computing. These are the big dogs that people will use. And nowadays, quite often, they're more or less being relegated to, many of them are being relegated to really high-performance servers for providing information to networks of PCs out there in the cloud. But there's still an awful lot of people using large mainframe computers where users will be sitting at a computer of their own or a terminal locally, and it handles all the processing, storage, and transaction for those kind of people. Now, a supercomputer. What is a supercomputer? One of the most famous brand names for supercomputers was Cray. And these are very, very high-speed, usually limited-purpose computers. They are meant for serious calculations that take lots and lots of cycles and bandwidth, lots of cycles to perform. For example, supercomputers might be calculating the next hurricane that hits the Gulf Coast, tracking it from when it starts off outside of Africa all the way up to the bay in Mobile. So supercomputers are very, very high-performance, high-speed computers, probably along the lines of what the original builders of computers thought they would be making someday. Well, what's an embedded computer? Well, they're all over the place. We just don't see them. An embedded computer would be in your car, running your car. There may be one in your refrigerator. There may be one in your watch, performing all sorts of functions for those devices. Those are called embedded computers. And then there's the microcomputer. The microcomputer is a personal computer. It's usually a desktop type computer. It's meant for you as an individual to use. There used to be another category in here called the mini computer, which was that's really meant to be an M right there, mini computer, which was really just a small version of a mainframe. And the mini computer has kind of disappeared because the microcomputer has gotten so powerful that nowadays it has taken over a lot of the jobs that the mini computer used to do. It can handle multiple users now on a microcomputer. It can serve as a server for a lot of data for a lot of different users. The microcomputer has displaced the mini computer, and it is the one that is probably the one we're most familiar with. And so we're going to talk about microcomputers a little bit more. Here's some classifications of microcomputers. The desktop computer is the one I'm sitting at right now. Well, no, as a matter of fact, it's not. I'm sitting at a laptop doing this, but I have a desktop in my office. It's a personal computer, usually has one monitor, although some of them have two. I have a couple on my machine. But it is what we use every day. It can run any number of different operating systems, and it can be used for just about anything that your imagination can come up with, from doing honest-to-goodness work, like word processing or spreadsheets, to accounting, to playing games and surfing the web or chatting with your old friends on Facebook. A tablet is a fairly recent development. It is a computer, that's true. It is generally a more or less of a special purpose type of computer in that it is not the best in the world for doing accounting function and word processing. They're small. Sometimes they don't have a lot of memory, but they are wonderful for many of the things that we do, such as research on the internet and surfing the web and chatting with our friends. They're very portable. You carry them any place you want to carry them. They're almost all wireless, and you can connect to things. And so what are we talking about here? How about iPads, right? Those Android tablets. Windows has got one now too, I believe. Microsoft's come out with some sort of a tablet as well. What about mobile computing? Well, what's mobile computing? Well, that's once again, that's like the iPhones and it's like the basically it's really describing an environment more than anything else, because it is a computer that you can carry around with you and still stay in touch with the office and do some serious work with it, because you are moving with it. It's connected to the internet, and I guess iPads fall into that category as well as smartphones do. And of course, we all know our smartphone, your iPhone and your Google Android phone and your Galaxy and all these things. It's amazing what we can do now in our hip pocket. Imagine, in our hip pocket, we carry a lot of power that allows us to access our bank account, send messages to our friend, check our email, just do any kind of thing that you need to do. As a matter of fact, some of my students may be accessing this video on the road with their smartphone, which they can do. So these are all of these types of devices that you see right here are classified as microcomputers because they have a microprocessor in them. That's what makes them microcomputers. So there's a little discussion about the different kinds of classes of computers. That concludes our lecture for this session, and we will be talking about software in the next one.